Hi, my name is Neal Damani, and this is my Lab 2 for Physics 2212, Lines of Charge. So to introduce the lab, what we did is an analysis of two pieces of charge tape from Lab 1 was redone to consider the charge of the tape as being uniformly distributed over the tape length. The charge of the tapes can be determined using two charge tapes with uniform charge distribution. A summary of the results from the experiment are shown, with the charge of the tape being positive 2.39 e to the negative eighth coulombs, and the tape being deficient of 1.495 e to the 11th electrons. For our introduction to some of the key concepts, we utilize Newton's second law, the gravitational force, as shown on the screen. And then we also utilize the electric field for a rod with uniformly distributed charge because we must treat the tape as having a uniformly distributed charge across its length. The observation point was perpendicular to the charge tape and was on the center line of the charge tape. The equation is shown on the slide. Another key concept was the electric force for Coulomb's law, equal to the product between the Coulomb constant K, which is 9 e to the ninth, and the quotient of between the two charges and the square of the distance between the charges, so Q1 times Q2 over the magnitude of the vector r squared times r hat. And then to get into some of our key assumptions, the first and the most important is that we assume that the charge on the tape is uniformly distributed over the tape length. Second is that the air resistance is ignored. And third is that both tapes have the same amount of charge. For the procedure from Lab 1, we repeated it where we created the U-tapes by placing one piece of tape on a table and taping the other on top of the first tape, ripping it off to create a charge. To observe the interaction between the U-tapes, and then we observed the interaction between the U-tapes and a few other items. Because of this, we're able to determine that the U-tape is positively charged because it was attracted to a negatively charged pen. With two tapes, they repelled, and then the U-tape was also attracted to a hand. The interaction between the suspended U-tape and the other U-tape when it repelled had a separation distance of 0.025 meters. For our free body diagram, our system was our suspended U-tape, and our surroundings were our held U-tape and the earth. For the suspended U-tape, the force up is the electric field from the held U-tape on the suspended U-tape. Force down is the force due to gravity. For the held U-tape, the force up is the holding force, and this force down is the electric force from the suspended U-tape on the held U-tape. For our experimental data and calculations, the tape length was 0.18 meters, our tape width was 0.019 meters, our tape surface area was 0.00342 meters squared, and the number of atoms was 3.42 e to the 17th atoms, which was the surface area over the area of an atom. And then for our vertical separation distance between the two tapes, it was 0.025 meters, and our tape weight was 0.01764 kilograms, not newtons. For our experimental data and calculations, we can use the equation for the electric field of a uniformly charged rod to estimate the charge of the tapes. We would set the magnitude of the electric force equation to equal to the magnitude of the gravitational force on the tape. So for our code, for our computational model, first we establish our constants, so things like the mass, the net charge, and then our constants of 9.81 and K, which is 9 e to the ninth. And then we established our electric field function and created the tapes, so the top tape and the bottom tape, using the line charges. Then we added up the individual electric forces to find the electric force. And then we utilized the model to create arrows for visualization. Here's the final visualization. Getting into our discussion, the charge of the tapes was Q equals 2.39 e to the negative eighth coulombs. Our deficient electrons were 1.495 e to the 11th electrons. And then note that for the suspended U-tape to float, the net force must be equal to 0. Some possible sources of error would be inaccurate measurements for the tape length, tape width, and the separation distance. And if the U-tape was held not parallel to the suspended U-tape, this would all be a result of human error, and then some of the errors due to the rounding during calculations could be due to inconsistent carryover of decimals. So what if we had modeled the tapes as a single point charge? We would have gotten a different answer. The line charge model has a greater charge than the point charge model with a difference factor of approximately 2.15. And the reason that they differ is because the line charge model considers the length of the rod in addition to the rod distance from observation point. In this case, the line charge value is closer to the real value, because it models the charge distribution on the tape more realistically than the point charge model, because tape's more of a rod-like structure rather than a point charge. Thank you.